There are some journeys that begin with a destination, a mountain to climb, an ocean to cross, a distant city waiting beyond the horizon. And then there are journeys that begin with a question. This is one of them. Imagine for a moment opening your eyes inside a silent spacecraft. There is no sound except the soft hum of life support systems, quietly reminding you that, for now, you are still part of the living universe. Outside your window, the stars appear unchanged, ancient, patient. The same stars that watched over the first human beings who ever looked toward the night sky and wondered what might exist beyond their reach. But directly ahead of you, where you would expect to find another star, another planet, or perhaps the faint glow of a distant galaxy, there is only darkness. Not the familiar darkness of empty space. Something deeper. A darkness with shape. A darkness that bends the light around it, as though reality itself has chosen to step aside. You are looking at a black hole. And although humanity has spent more than a century studying these objects, there is still something strangely unsettling about them. Because black holes do not merely challenge our understanding of the universe, they challenge our understanding of understanding itself. There are mysteries in science that eventually become familiar. The planets that once inspired myths became places. Lightning became electricity. The stars became suns, scattered across an unimaginably large cosmos. But black holes have resisted that transformation. Even now, they remain strange. Perhaps that is why we continue returning to them. Not because we expect easy answers, but because they remind us that the universe still possesses secrets. The story of black holes begins, as so many stories in modern physics do, with a man who was not trying to discover them. In 1915, Albert Einstein introduced the world to general relativity, a new way of understanding gravity. Until then, gravity had been described as a force, an invisible attraction between objects. But Einstein proposed something far stranger. Mass, he suggested, bends space and time themselves. The Earth does not orbit the Sun because it is being pulled through space. It moves through curves that the Sun creates within the fabric of reality. It is a beautiful idea, elegant, almost poetic, and, like many beautiful ideas in science, it led to consequences that even its creator found difficult to accept. Shortly after Einstein published his equations, another physicist named Carl Schwarzschild discovered something remarkable hidden within them. Under the right conditions, gravity could become so extreme that space would curve inward without limit, a region from which nothing, not matter, not light, not even information, could escape. Einstein himself never believed such objects would truly exist. The equations allowed them. Reality, he assumed, would surely forbid them. History, however, has a habit of disagreeing with even the brightest minds. For decades, black holes existed only as mathematical curiosities. Strange solutions buried within notebooks. Thought experiments discussed quietly among physicists. Meanwhile, the rest of humanity continued imagining the cosmos in more familiar ways. The night sky was filled with stars, planets, and distant galaxies. Black holes belonged to the realm of speculation, and yet the universe had been creating them long before anyone gave them a name. Every time a sufficiently massive star reached the end of its life, gravity resumed a patient task, that had begun billions of years earlier, pulling, compressing, refusing to stop. Eventually, the star would collapse beneath its own weight, leaving behind something so dense that the normal rules of existence appeared to break down entirely. There is something humbling about that. Black holes do not require observers. They do not care whether they are understood. For billions of years, they drifted silently through the cosmos while humanity was still learning to make fire. I often wonder what our ancestors would have thought had they known. Imagine standing beside an ancient campfire 10,000 years ago. The stars overhead appear eternal, and somewhere among them are objects so strange that they would not even become imaginable until the invention of modern mathematics. The universe has always been larger than our stories. Perhaps that is one of its greatest gifts. As the 20th century continued, evidence slowly began to accumulate. Stars appeared to orbit invisible companions. Galaxies behaved in unexpected ways. Something unseen was hiding among the stars. Then, in 2019, humanity achieved something that would have seemed impossible to every generation before us. For the first time, we saw one, or rather, we saw its shadow. A ring of light surrounding a darkness at the center of the galaxy, Messier 87. A photograph taken not by a single telescope, but by an entire planet working together. The image was blurry, imperfect, and absolutely extraordinary. After a century of equations and speculation, black holes had finally become something more than ideas. They had become places, real places, places no human being will ever visit. And perhaps that is why they continue to fascinate us. Human beings are drawn to frontiers, the top of mountains, the depths of oceans, the distant edges of maps, and black holes represent the ultimate frontier, not because they are far away, but because they mark the boundary between what we understand and what we do not. There is a question hidden within every black hole. Not, what is it? Science has answered that, at least partially. The deeper question is, what happens if we continue? What happens if we ignore every warning written into the laws of physics and simply keep moving forward? Tonight, we are going to do exactly that. Over the next few hours, we will leave behind familiar stars. We will watch time itself begin to misbehave. We will cross a boundary from which nothing has ever returned. And together, we will travel toward one of the few places in the universe where science is willing to admit something extraordinary it does not yet know. So, settle in. Allow the universe to grow a little stranger around you, because our journey is about to begin. And somewhere ahead, waiting patiently in the darkness, is a question that has followed humanity for more than 100 years. What would happen if you fell into a black hole? Before we continue our journey, we should take a moment to understand what is waiting for us. After all, it is difficult to fall into something if we do not first know what it is. Black holes occupy a curious place in the human imagination. They are often described as cosmic vacuum cleaners, endlessly pulling everything around them into an inescapable abyss. Movies portray them as portals to distant galaxies. Books imagine them as gateways to other universes. And while some of these ideas are fascinating, The truth is both simpler and stranger. A black hole is not a hole. At least, not in the way the name suggests. It does not exist as an opening in space. There is no tunnel floating through the cosmos, waiting to swallow unsuspecting travelers. Instead, a black hole is a place where matter has been compressed to such an extraordinary degree that gravity becomes the dominant force in its surroundings. To understand how this happens, we must begin with stars. Stars, despite their beauty, spend most of their lives engaged in a quiet struggle. Gravity constantly attempts to pull them inward. Meanwhile, nuclear fusion pushes outward. For millions or billions of years, these two forces remain in balance. Our sun is living this delicate compromise at this very moment. Every second, gravity attempts to collapse it. Every second, fusion refuses. It is an arrangement that has lasted for nearly 5 billion years. But nothing in the universe lasts forever. Eventually, every star exhausts the fuel that sustains it. For stars like our sun, the ending is relatively gentle. They expand into red giants before leaving behind dense remnants known as white dwarfs. But the most massive stars experience a considerably more dramatic conclusion. Imagine a star 20 times more massive than the sun. For millions of years, it burns brightly, unaware of the fate waiting patiently at the end of its existence. Then, one day, the balance ends. Fusion stops, and gravity, which has been waiting quietly for millions of years, finally wins. The collapse happens with astonishing speed. In mere moments, a star larger than entire planetary systems begins falling inward upon itself. The resulting explosion, a supernova, is among the most energetic events in the universe. For a brief time, a single star can outshine an entire galaxy. And then, when the light fades, something extraordinary may remain. If the star possesses enough mass, there is no known force capable of stopping the collapse. Not atomic pressure, not neutron pressure. Nothing. Gravity continues compressing matter until it creates an object unlike anything else in existence. A black hole is born. There is something almost unsettling about this process. Black holes are not exotic visitors from another dimension. They are the corpses of stars, ancient suns that died in ways the universe never intended us to witness. And yet, they are everywhere. Astronomers now believe there may be hundreds of millions of black holes within the Milky Way alone. Hundreds of millions. Some drift silently through interstellar space. Others exist in binary systems, locked in endless dances with companion stars. And at the center of nearly every large galaxy, there appears to be something even more extraordinary. A supermassive black hole. Our own galaxy is home to one, known as Sagittarius A*. It contains roughly 4 million times the mass of our sun. And yet, despite its unimaginable size, it occupies a surprisingly small region of space. This is one of the strangest things about black holes. They are defined not by what they contain, but by how little room they require to contain it. If the Earth somehow became a black hole, something that is physically impossible, thankfully, it would need to be compressed into an object smaller than a marble. The sun would fit into a sphere only a few kilometers across. Gravity, it seems, is remarkably efficient. There is another misconception about black holes that deserves attention. Many people imagine them as cosmic predators, consuming everything nearby. But black holes are surprisingly well behaved. If our sun were instantly replaced by a black hole of equal mass, the Earth would continue orbiting exactly as it does today. The difference would not be gravitational. It would simply become very cold and very dark. Gravity depends on mass, not appearance. A black hole with the mass of the sun pulls no harder than the sun itself. Its true danger emerges only when you venture too close. Which brings us to one of the most important concepts in our journey: the event horizon. If black holes possess a border, this is it. Imagine standing beside a waterfall in a small boat. Far upstream, the current is gentle. You can still turn around. You remain free to choose your direction. But as you drift closer to the edge, there comes a point where the current becomes too strong. A point beyond which escape is no longer possible. The event horizon is something like that. It is not a physical surface. You would not collide with it. There is no wall, no sign, no cosmic warning announcing your arrival. And yet, it represents one of the most significant boundaries in the entire universe. Cross it, and every possible future leads inward. Nothing, not rockets, not light, not information itself, can ever return. That is because the escape velocity beyond the event horizon exceeds the speed of light. And according to everything we currently understand about physics, nothing can travel faster than light. The universe has many speed limits. This one appears absolute. There is a peculiar beauty in that. For centuries, humanity has explored frontiers, mountains, oceans, the moon, and each frontier shared one characteristic. Someone could always come back and tell the story. Black holes are different. They are the first places we have discovered where the universe itself refuses to provide eyewitnesses. Whatever lies beyond the event horizon remains hidden, not because we lack the technology to observe it, but because reality appears to have written the word no across its entrance. And still, we continue asking questions. Perhaps that is the most human thing of all. In 2019, the world held its breath as the Event Horizon Telescope collaboration released the first image of a black hole, or more accurately, the shadow it cast against the glowing material surrounding it. It was not the spectacular image many people expected. There were no swirling portals or brilliant explosions, only a ring of light surrounding an absence. And somehow, that made it even more profound, because for the first time in human history, we were not looking at a planet or a star. We were looking at a place where our understanding of reality begins to fail. There is something deeply poetic about that. After all, every generation inherits mysteries from the one before it. For ancient civilizations, it was the movement of the planets. For modern humanity, it may be black holes. Questions patiently waiting in the darkness for someone curious enough to ask them. And tonight, we are doing more than asking. We are approaching, because now that we understand what a black hole is, there is only one thing left to do. Our engines are running. The stars behind us are beginning to fade into the distance, and ahead, beyond the safety of everything we have ever known, the darkness waits. In our next chapter, we will do something no human being has ever done. We will point our spacecraft toward the event horizon and continue forward. There is a moment before every great journey when turning back is still possible. The mountain remains unclimbed. The ocean remains uncrossed. The unknown remains safely distant. This is that moment. Behind you, the universe stretches endlessly in every direction. Thousands of stars shine against the darkness, each one carrying its own history. Some are younger than our sun. Others were already ancient when the earth was still taking shape. For your entire life, these lights have represented permanence, a familiar backdrop to humanity's story. And yet, tonight, for the first time, they feel strangely fragile. Because directly ahead of you, occupying an ever-growing portion of your view, is something that should not exist. A region of space where reality itself appears to bend inward. The black hole does not glow. It does not announce its presence. It simply waits, patiently, silently. There is something unsettling about encountering an object that cannot be seen directly. Every other destination in human history has offered something recognizable: a coastline, a mountain peak, a distant planet. But a black hole presents only absence. It is less like arriving somewhere and more like approaching a question. Your spacecraft continues forward, slowly at first. There is no reason to rush. After all, this may be the strangest experience consciousness has ever attempted to imagine. At a great distance, the black hole appears almost ordinary. If not for the stars behind it, behaving in impossible ways, you might mistake it for an empty patch of sky. But the closer you move, the more the universe begins revealing its secrets. The first thing you notice is that space itself no longer behaves normally. Stars that should remain fixed begin appearing in unexpected places. Light bends. Constellations stretch and curve around the darkness ahead. It is as though the cosmos has become a reflection in disturbed water. This phenomenon is known as gravitational lensing. According to Einstein's theory of general relativity, gravity is not simply a force acting across space. It is the curvature of space itself. And near a black hole, that curvature becomes extreme. Light, despite possessing no mass, follows the shape of the universe around it. Imagine placing a heavy stone on a stretched sheet of fabric. Everything nearby begins sliding toward the center. Now imagine replacing that stone with something millions of times heavier than the sun. The fabric does not merely bend, it folds. The stars you see around the black hole are not where they appear to be. Some of the light reaching your eyes has traveled around the black hole entirely. You are seeing the backs of stars. Entire regions of the universe become visible simultaneously, their light twisted into luminous arcs surrounding the darkness. Astronomers sometimes describe this effect as the universe creating a mirror from gravity itself. And standing before it, it is difficult to disagree. There is an almost dreamlike quality to the sight. A ring of distorted starlight now surrounds the black hole like a halo. It is beautiful, and perhaps That is what makes it dangerous. Human beings have always been drawn toward beautiful mysteries. The sea has its sirens, the night sky has its stars, and black holes possess something uniquely compelling. They are places where the universe openly admits it still has secrets. Your instruments continue reporting normal conditions. The hull remains stable. The engines hum quietly beneath your feet. And yet, something has begun to change. Not around you, within time itself. At first, it is impossible to notice. Time, after all, is not something human beings are accustomed to observing directly. It is simply there, reliable, consistent, or at least, we assume it is. But Einstein taught us something remarkable more than a century ago. Time is not universal. It stretches, it compresses, and gravity affects it. The stronger the gravitational field, the slower time passes. This phenomenon, known as gravitational time dilation, is not science fiction. It has been measured repeatedly. Even the clocks aboard GPS satellites must account for relativistic effects to function correctly. But near a black hole, these effects become almost impossible to comprehend. As your spacecraft continues its descent, your clock remains perfectly normal. Your heartbeat remains unchanged. Every thought occurs exactly as it always has. And yet, to a distant observer watching from Earth, something extraordinary has begun to happen. You are slowing down. Not physically, temporally. Imagine that someone on Earth is watching your approach through an impossibly powerful telescope. They wave. You wave back. At first, there is no difference. Then, gradually, your movements begin to lag. Seconds become slightly longer. Minutes stretch. Hours drift apart. You would not notice any of this. From your perspective, time remains faithful. It always does. But the universe no longer agrees on how quickly your life is unfolding. This is one of the strangest truths in modern physics. Time is not something we move through together. Each of us carries our own. And near a black hole, those differences become impossible to ignore. The stars behind you continue changing. Their light shifts toward red as gravity steals energy from the photons reaching your eyes. This effect, known as gravitational redshift, causes the universe itself to appear subtly altered. Colors fade, light stretches, reality begins behaving less like a place and more like an equation. There is a peculiar loneliness in this realization. For your entire life, you have shared time with everyone who has ever known you. Every conversation, every sunrise, every moment. But now, little by little, you are beginning to drift away from the rest of existence, not through space, through time. Imagine looking back toward Earth. Somewhere out there is every person who has ever lived, every city, every song, every memory. And with each passing moment, you are becoming slightly less synchronized with all of them. It is an isolation unlike any humanity has ever known. There is no anger in the black hole, no intention. It does not pull you inward out of malice. It simply follows the laws written into the fabric of reality billions of years ago. And perhaps that is what makes it so profound. The universe does not need to hate us to remain indifferent. Ahead, The event horizon continues growing larger. It remains invisible, of course. There are no warning lights, no signs marking the point of no return. And yet, every kilometer brings you closer to a boundary that has never been crossed by anything that later returned to tell the story. For now, however, you still have a choice. Your engines remain capable of turning around. The stars behind you still offer a path home. This is the last chapter in which escape remains possible. And somewhere deep within yourself, a question begins to emerge. If humanity has spent centuries asking what lies beyond the event horizon, how could anyone willingly turn back now? In our next chapter, we will discover something even stranger. Because while your journey continues normally, the rest of the universe is about to witness something entirely different. And before long, time itself will stop making sense. There is a reason human beings trust clocks. They are honest, or at least they appear to be. A second passes, then another. The rhythm feels universal, reliable. It is one of the first things we learn about the world, that time moves forward, carrying all things with it. Empires rise, mountains erode, stars are born and die. Everything, from the smallest atom to the largest galaxy, seems to agree on this simple arrangement. Time moves, and it moves for everyone. Or so we believed. Your spacecraft continues its slow descent toward the black hole. Inside the cabin, nothing feels unusual. The air remains warm. The instruments continue their quiet work. Your heartbeat has not changed. If someone were to ask you how much time has passed since beginning this journey, you would answer without hesitation, minutes, perhaps hours. Everything still feels familiar. And yet, far away, someone observing your approach would tell a very different story. This is where our journey begins to separate into two realities. One belongs to you. The other belongs to the rest of the universe. And somehow, both are equally true. Imagine an observer waiting safely aboard a distant station, millions of kilometers from the black hole. They watch your spacecraft through a telescope unlike any humanity has ever built. At first, they see exactly what you see, a ship moving steadily toward darkness. But as you draw closer to the event horizon, something strange begins to happen. You slow down, not because your engines have changed, not because you are resisting the black hole's pull. You simply appear to move more slowly. Your gestures become delayed. Your voice, transmitted over radio, grows deeper and more stretched. Second by second, the difference becomes more noticeable. To them, your clock begins to fail. To you, theirs does. This is the extraordinary consequence of Einstein's universe. Time is not a river carrying everyone downstream together. It is something far stranger. It bends, and near a black hole, it bends dramatically. There is an equation in general relativity that describes exactly how much time slows in the presence of gravity. Physicists have tested it countless times, and every experiment has returned the same unsettling conclusion. Time is not absolute. It never was. We simply evolved in a part of the universe where it behaves politely. Black holes, however, are under no obligation to be polite. As you continue your descent, the discrepancy grows. Hours pass for you. Days pass for the distant observer. Eventually, years, there is a peculiar sadness hidden within this thought. Imagine beginning your journey at the age of 30. Imagine spending a few hours approaching the event horizon, and then imagine returning, somehow, to discover that centuries have passed. Everyone you have ever known would be gone, every city rebuilt, every language changed. History itself would have continued without you. Science fiction has explored this idea for generations, but the remarkable truth is that it emerges naturally from Einstein's equations. Time travel to the future, in a sense, is possible. The universe merely demands an extraordinary price. As your spacecraft drifts closer to the black hole, another phenomenon begins to reveal itself. The light from the outside universe grows increasingly strange. Stars ahead appear normal enough, but those behind you begin accelerating. At first, the changes are subtle. A star shifts position. A distant galaxy brightens unexpectedly. Then the effect becomes impossible to ignore. The universe is speeding up. Remember, your clock has not changed. From your perspective, time remains stubbornly ordinary. But because the rest of the cosmos is moving faster relative to you, external events begin unfolding at an extraordinary pace. Imagine watching Earth through an impossibly powerful telescope. Clouds race across continents. Day becomes night. Night becomes day. Seasons pass in moments. Cities illuminate and vanish. Civilizations rise and fall. Generations live entire lives while you sit quietly in your spacecraft, drifting toward a destination from which no one has ever returned. It sounds impossible, and perhaps that is why black holes continue captivating us. They transform abstract concepts into experiences. Near a black hole, time is no longer something measured. It becomes something observed. There is a profound loneliness in witnessing the future unfold without you. To watch history continue at impossible speeds, to realize that while you remain present, the universe has quietly moved on. I sometimes wonder if this is what eternity would feel like. Not endless life, but endless separation. The philosopher in me cannot help but notice something poetic here. Human beings spend their lives wishing for more time, more years, more moments, more opportunities. And yet, standing at the edge of a black hole, we discover that time itself may not be the gift we imagined. Because time only has meaning when it is shared. 1,000 years alone remains loneliness. Even among the stars. There is another question physicists have wrestled with for decades. What happens at the event horizon itself? According to your experience, eventually you cross it. There is no explosion, no sudden flash of light, no dramatic moment announcing your arrival. You simply continue moving forward. But, to the distant observer, something entirely different occurs. You never arrive. As you approach the event horizon, time dilation becomes increasingly extreme. Your movements slow further. Your image grows dimmer and redder. Eventually, you appear frozen at the edge of the black hole, suspended forever in time. The last light from your spacecraft stretches into invisibility, and then, for all practical purposes, you disappear. This is one of the greatest paradoxes in modern physics. From your perspective, you crossed the horizon. From theirs, you never did. Two observers, two realities, both correct. It feels less like science and more like a disagreement between the universe and itself. Physicists still debate the deeper implications of this. Some believe information somehow remains encoded on the event horizon. Others suspect we are missing a fundamental piece of reality. There are even hypotheses suggesting that space and time themselves behave differently than we currently understand. Black holes, it seems, remain excellent at keeping secrets. And perhaps that is their true purpose. Not to destroy matter, not to consume stars, but to remind us that our understanding of the cosmos remains unfinished. There is a certain humility in that realization. After centuries of discovery, after walking on the moon and photographing galaxies billions of light years away, humanity still encounters places where the universe simply shrugs and says, "There is more." Ahead of you, the event horizon continues waiting, closer now than ever before, and somewhere beyond it lies a region no equation can fully describe. Your clock continues ticking, your heartbeat remains steady, but the rest of the universe is already becoming history. In our next chapter, there will be no turning back, because for the first time in this journey, we will cross a boundary that has never shared its secrets with anyone. The event horizon awaits, and beyond it, every possible future points inward. There are moments in life that divide everything into two categories: before and after. The first breath taken as a child, the last time you see a place you once called home, the moment humanity first set foot on the moon. Some boundaries are physical, others exist only in memory. And then there are boundaries, like the one waiting ahead of you now. Boundaries that do not merely separate places, they separate realities. For all of human history, every frontier has shared one comforting characteristic: someone could return. Sailors crossed oceans and came home with stories. Astronauts traveled to the moon and left footprints in the dust. Even the most distant spacecraft continue sending messages across the darkness. The event horizon offers no such comfort. It is the first destination humanity has ever imagined from which the universe itself forbids a return. And yet, as your spacecraft continues forward, nothing appears different. That is perhaps the strangest part of all. There are no warning lights, no cosmic alarm, no sudden sensation announcing that you have reached the edge of the possible. The event horizon is not a wall. It is not a surface. You cannot touch it. If black holes possess a shoreline, it is one made entirely of mathematics. Somewhere ahead of you exists an invisible sphere surrounding the black hole. Cross it, and every path through space and time leads to a single destination: the center, the singularity, the place where our equations quietly surrender. Imagine standing in a river. At first, the current is gentle. You can walk freely in any direction. But farther downstream, the water grows stronger. Eventually, there comes a point where swimming back becomes impossible. Not because you are weak, because the river itself has become stronger than choice. That is the event horizon, the universe's final current. Your instruments continue functioning normally. The cabin lights remain steady. If you did not know what awaited ahead, you might mistake this journey for any other. And perhaps that is why black holes feel so unsettling. The greatest boundary in the cosmos does not announce itself. It simply allows you to continue. There is a profound lesson hidden within that. Human beings often imagine extraordinary experiences as dramatic things, explosions, thunder, light. But reality is frequently quieter than our imaginations. Even now, as you approach a place no conscious being could ever describe, the universe remains silent. Outside your window, the ring of distorted starlight surrounding the black hole has grown immense. The stars themselves appear warped beyond recognition. Some seem duplicated. Others stretch into luminous arcs around the darkness. It is as though the universe has begun folding in upon itself. And perhaps, in a sense, it has. You glance once more toward the distant stars behind you. Somewhere among them is Earth, a pale blue world orbiting an ordinary star. Home. It is a curious word. Home is rarely a place we appreciate fully until we begin leaving it behind. Somewhere on that distant world, oceans continue moving with the tides. Rain falls against windows. Children ask questions about the stars. And for the first time since beginning this journey, you realize something with complete certainty. You will never see it again. There is no tragedy in this realization, only truth, because every possible future from this moment forward leads in one direction, inward. Imagine sending one final message. What would you say? Would you describe the impossible beauty of gravitational lensing? Would you tell humanity that Einstein was right? Or perhaps, faced with the largest mystery in existence, you would simply say, goodbye. There is something deeply human about wanting our final words to matter. Perhaps because words are among the few things that occasionally outlive us. You activate the transmitter. The signal leaves your spacecraft at the speed of light. For a brief moment, it races toward the distant universe. But every message has a final sentence. Every conversation eventually reaches silence. And soon, your ability to communicate with the cosmos will come to an end. This is another strange property of the event horizon. Once crossed, no information can escape. Not messages, not memories, not even light itself. You are about to become the most isolated person who has ever existed. Human beings evolved together. Everything about us assumes companionship. We speak because others listen. We tell stories because others remember. We look toward the stars because we hope someone, somewhere, may be looking back. But beyond the event horizon, there is no audience, only you and the black hole. There is an old philosophical question that asks, if an event occurs and no one can ever observe it, did it truly happen? Black holes seem uniquely designed to make us uncomfortable with that question, because beyond the horizon, experiences continue. Your thoughts continue. Your journey continues. And yet, the rest of the universe will never know. It is a strange kind of disappearance, not death, not yet. Simply separation. Ahead of you, the invisible boundary approaches, and then nothing happens. No sensation passes through your body. No flash illuminates the cabin. Your heartbeat remains steady. Your clock continues ticking. If this is a supermassive black hole like Sagittarius A*, you might not even realize the moment has arrived. That, perhaps, is the most astonishing truth of all. You have crossed the event horizon. You are now inside a black hole. Behind you lies the entire observable universe. Ahead of you lies something no human language was ever designed to describe. And somewhere far away, a distant observer continues waiting patiently, watching your image, frozen forever at the edge of the darkness. To them, you never crossed. To you, the crossing is already behind you. Two realities, one universe, both true. There is no turning back now, not because your engines have failed, not because you lack the necessary fuel, but because the concept of back no longer exists. Inside a black hole, space itself has changed. Outside the horizon, moving toward the center, was a choice. Inside, it has become as inevitable as tomorrow. Imagine waking one morning to discover that every road on Earth leads south. Every step, every direction, no matter where you walk, you always arrive at the same destination. That is what the singularity has become. Not a place you are traveling toward, a future you cannot avoid. For the first time in this journey, the universe has removed choice from the equation. And perhaps that is why the event horizon feels so significant. It is not merely the edge of a black hole. It is the edge of freedom itself. Still, there is something extraordinary about being here. For a brief moment, against all odds, consciousness has crossed into a region of reality that the universe never intended to explain. And if black holes truly represent the limits of human understanding, then tonight we have finally stepped beyond the border. In our next chapter, the journey becomes stranger still, because somewhere ahead, hidden beneath layers of mathematics and mystery, waits an idea so extraordinary that even physics struggles to describe it. The singularity, the place where space ends, where time ends, and where our understanding of the cosmos quietly comes undone. Our journey is almost over. Somewhere behind us lies Earth, so distant now that even memory struggles to hold on to it. The oceans, the forests, the quiet lights shining from bedroom windows late at night. For most of human history, those things were the entirety of existence. Everything we loved, everything we feared, everything we could imagine. And yet, somehow, a species born on a small world beneath an ordinary star learned to ask questions about black holes. There is something extraordinary about that. Black holes are, in many ways, the least human places in the universe. They are dark where we seek light, silent where we seek conversation, indifferent where we seek meaning. They do not care whether they are understood, and still we continue trying to understand them. Perhaps that is why they fascinate us, not because of what they are, but because of what our fascination says about us. Human beings have always been creatures of impossible curiosity. Thousands of years ago, our ancestors looked at the horizon and wondered what existed beyond it. Then we crossed it. Later, we looked toward the moon and asked the same question. And one day, we stood upon its surface. Every generation inherits mysteries from the one before it, and every generation quietly assumes that it will be the one to solve them. Black holes challenge that assumption. They stand before us as reminders that some questions may outlive entire civilizations. Imagine a future 1,000 years from now. Humanity may have colonies among the stars. Perhaps our descendants will travel between worlds as casually as we once crossed oceans. They may possess technologies so advanced that they would appear indistinguishable from magic to us. And yet, I suspect they will still look toward black holes with the same mixture of wonder and uncertainty that we do today. Because some mysteries are not waiting for better tools. They are waiting for better minds. Or perhaps they are waiting for something else entirely. There is a phrase often attributed to the writer and scientist Arthur C. Clarke. Any sufficiently advanced technology is indistinguishable from magic. I sometimes wonder if the opposite is also true. Perhaps any sufficiently profound mystery is indistinguishable from philosophy. Black holes force us to ask questions that science alone cannot answer. What does it mean for information to disappear? Can something truly cease to exist? Is time a fundamental part of reality, or merely a feature of our perspective? And perhaps the most human question of all, why do we feel compelled to understand a universe that owes us no explanations? There is no survival advantage in contemplating singularities, no evolutionary benefit in wondering what lies beyond the event horizon. And yet, here we are, a collection of atoms that somehow learned to ask where atoms come from, a species that emerged from the Earth and became curious about the stars. Carl Sagan once said that we are a way for the cosmos to know itself. It is a beautiful thought. Perhaps black holes represent the limits of that self-awareness, the places where the universe looks back at itself and admits, I do not yet understand. There is something comforting in that idea. We spend so much of our lives feeling as though we should have answers. Answers about who we are, answers about where we are going, answers about what all of this means. But the universe itself appears to be under no such pressure. It is comfortable with uncertainty, comfortable with silence, comfortable with remaining mysterious. Maybe we should learn from it. Somewhere, right now, real black holes continue drifting through the darkness. Ancient objects older than humanity itself. They existed before the first stories were told, before the first fires were lit, before the first eyes ever looked toward the night sky, and long after our species is gone. Whether in 1,000 years or 1,000,000, they will likely remain, patiently orbiting through a universe that has forgotten our names. At first, that thought can feel unsettling. But stay with it for a moment, because there is another way to see it. In a universe filled with billions of galaxies and countless stars, consciousness is extraordinarily rare. As far as we know, the cosmos has spent nearly 14 billion years producing black holes, and only a brief moment producing you. Perhaps that makes your existence the greater miracle. After all, black holes do not wonder about humanity. Humanity wonders about black holes. The universe created both, but only one of them pauses to ask questions. And maybe that is enough. Maybe meaning was never something hidden inside the stars, waiting to be discovered. Maybe meaning is what happens when a conscious mind looks at the night sky and decides that its mysteries matter. There is an image I return to whenever I think about black holes. Not an image captured by a telescope, a simpler one, a child standing beneath a sky full of stars, looking upward for the very first time, feeling that strange mixture of curiosity and insignificance that has accompanied our species since the beginning. That child does not know about singularities, or event horizons, or Hawking radiation, but they understand something essential, that the universe is vast, and that it is worth wondering about. Perhaps that is the real purpose of black holes. Not to serve as cosmic laboratories, not to challenge our equations, but to remind us that wonder still exists. Because as long as there are questions larger than ourselves, there will always be reasons to keep looking upward. And so, our journey comes to an end. We never discovered what lies beyond the singularity. We never learned whether information truly disappears. We never solved the deepest mysteries hidden within the darkness. But perhaps that was never the point. Perhaps the point was simply this. For a brief moment in the history of the universe, matter became conscious. It learned to dream. It learned to ask questions. And one quiet night, it imagined falling into a black hole. As the stars slowly fade around us, and the darkness of the cosmos grows still once more, remember this: black holes may represent the limits of human understanding. But the fact that we can recognize those limits at all may be one of the most extraordinary things the universe has ever done. Good night, and wherever your thoughts may wander among the stars tonight, may they always find their way back home.